In this tutorial, we're gonna learn how to make this Houdini-like effect in Blender. First, we will make this using FlipFluid add-on, and after I will show you how we can do the same using vanilla Blender tools. In a new Blender scene, we can delete the point light as we won't need it. I'm gonna scale the cube to make the ground. I will also move it down on the Z-axis so the top of the cube is sitting just on the red line. We can also scale it on the X and Y axis to cover the area we want to render. Now we can add the UV sphere that we are going to use as an inflow object. I will move it up to sit just above the ground. We can copy the UV sphere and move it to the side where we want the other inflow object to be. Now we can add the object that we will use as a brush. I'm gonna add a cube and scale it on a y-axis. And we can move the cube where we want the brush to start moving from. I added a few loop cuts just to get more even spread geometry. And I subdivided the cube to get more geometry so I can displace it. Now we can add the displace modifier, add a new texture, and under texture here, change from image to cloud. You can play with the size here to get the shape that you want. I also added subsurf modifier just to smooth out the mesh. This is just one of the ways to get this done, and you can make this brush with sculpting or other methods and go detail as much as you want, depending on what kind of trails or results you are trying to achieve. When I was happy how it looked, I applied all the modifiers. Also make sure that the brush is sitting above the ground. Now to animate it, we can add a keyframe on a frame 10 at the current position. Then we can move to frame 160 and move the cube on a y-axis and add another keyframe. I will also make interpolation linear. Now we can add a cube that is going to be used as a domain for the fluid simulation. Make sure that the cube is encompassing the entire area where you plan for the simulation to happen. But try not to go too far off, as this will increase the baking time. Now we are ready to open up the FlipFluid add-on, which you can find here on the side panel after you installed it. While this cube is selected, we are going to click on the Create Domain. As you can see, we are getting the warning that the file is not saved, so at this point, if you haven't done so, you can save the file. We're going to adjust the resolution later on. First, we are going to scroll down here where it says Add Remove Objects and expand this menu. We can select the sphere and click on the inflow, and do the same for the other sphere. For the brush in the ground, we're going to click on Obstacle. Before we start changing the settings under the main, I want to animate the inflow objects. We can select the sphere, and on the frame 1 in the Physics tab, we can add a keyframe on this Enable checkmark. Do the same on the other sphere. Then we can move on the frame 5 and uncheck the Enable and add a keyframe. And again, we will do the same on the other sphere. This will restrict the inflow of the fluid to just these first 5 frames. I also want to animate the brush, not affecting the fluid towards the end of the simulation. We can go to the frame 119 and add a keyframe on Enable here, then move one frame to 120 and uncheck the Enable and add a keyframe. Now we have everything ready and we can adjust the settings on the domain under the Physics tab. First, we are going to the World tab here and we are going to change the scale to 2, as Blender handles simulations better when they are scaled up. Now we are going to turn on the viscosity and change the base to 20. I also turned on the surface tension and sheeting effect and left the values on default. Now we can go to the Advanced tab and change the simulation from Flip to Epic, which is usually better for the viscous simulation, but you can test the both. I also changed the minimum frame subsampling to 5, but be careful as this will slow down the baking a lot. Under simulation, we can now change the resolution, and you can start with the smaller numbers and start increasing when you're happy with how everything looks. But the higher the number, the slower the bake will be. Before we bake, we want to activate the color attributes so we are able to take advantage of mix box that comes with FlipFluid, so we can mix the colors. You can select the sphere and under the physics scroll down to the geometry attributes and add color attribute plus mixing. You will get a warning that it might cause crashes when it's enabled, but I haven't had any issues. But if you do get any problems, you can use the command line options on the bottom for baking and rendering. We can enable the same on the second sphere and I will change the color to orange. You can also select red, green or blue color, which later can be split in the shader editor for more mixing options. But for this, I will just stick with white and orange. Now we are ready to bake and this might take a few minutes. If you're getting these empty areas, you can just move the ground lower or brush higher and we can bake again. This looks better now. To enable color mixing, we can go to the material preview, open up the shader editor. We can add a new material for the fluid object. We're going to add the attribute node, and for the attribute, you're going to write flip_color. Then connect the color to the color of the BSDF shader, and we have this orange and white mixing. To make this look smoother, we can go to this smooth modifier and increase the factor to 1.5 and repeat to 8. This all depends on what are you trying to achieve. Now to do this in Vanilla Blender, we are going to use the same objects. While the cube is selected, we can go to the physics properties and we're going to click on the fluid and select the main under the drop-down menu. For the brush and the ground, we're going to do the same, but under the drop-down menu, we're going to select the effector. For the sphere, we're going on fluid and select the flow. We can scroll down and change the flow type from smoke to liquid and flow behavior from geometry to inflow. We also need to animate inflow similar like we did with FlipFluid, and all this needs to be done on both spheres. Here under the scene properties, under the unit, we can change the scale to 2, similar like we did in the FlipFluid. Now we can select the domain and under the physics, change the domain type from gas to liquid, and if you press play, we can see that we have a fluid simulation. We can turn off the visibility of the sphere so we can see better what's happening with the fluid. For the resolution, we are starting with a smaller number for the faster preview. I'm changing the CFL number to 5, maximum time steps to 25 and minimum to 5 to match with what we did in FlipFluid. We can scroll down and change the simulation to epic. We can expand the diffusion tab and turn on diffusion and high viscosity. And if you press play, we have this viscous simulation. To make it smoother, we can add the smooth modifier, same like we had in a FlipFluid simulation, and we can set it to shade smooth. When you're happy how it looks, you can bake the simulation. Under the cache here, you can change the type to all and bake the simulation. I will increase the resolution and press bake all. This again can take a long time depending on your computer, but after it bakes, we can preview it in real time. Also have in mind that when you increase the resolution, the behavior of the simulation might slightly change comparing to what we have with the low res, so you might need to tweak a few things and bake again. The problem with this method is that there is no easy way to achieve the color mixing like we had in the FlipFluid. It will require complex geometry node setup or Python scripting. If anyone is interested in geometry node setup, leave the comment below. I hope this was helpful and you learned something new. Thanks for watching.